Our video is about gas laws. The first gas law we're going to talk about is Boyle's law. Boyle's law is the relationship between pressure and volume when temperature is held constant. The basic equation for Boyle's law is P1 times V1 equals P2 times V2. That means pressure and volume are indirectly related, and in a reaction, the beginning pressure and volume should equal the resulting pressure and volume. Alright, so in our problem, we are trying to find the second volume. So you have the volume of your first and your pressure in kPa, which stands for kilopascals. Since you have kilopascals in both the numerator and the denominator, they would cancel each other out, leaving you with just milliliters, which is what you want for volume. If you do all the math together, you should get 158 milliliters for your second volume. Alright, the next law we're going to talk about is Charles' law. Charles' law is the relationship between volume and temperature. They are directly related, meaning their basic equation is V1 divided by T1 equals V2 divided by T2, meaning the first volume and temperature, you divide them, and they should equal the second volume and temperature of your reaction. In our problem, we are trying to find the second temperature. So you do first have to convert to Kelvins by adding 273. Once you get that, you add your values in, and since you have 2 liters, they cancel each other out, leaving you with Kelvins. Now the problem asks you to find it in Celsius, so you want to subtract 273 from your answer in Kelvins, and you get 332 degrees Celsius. Alright, our third law we're going to talk about is Guy-Lussac's law. It is the relationship between pressure and temperature. They are directly related, and so you divide them. So it's P1 divided by T1 equals P2 divided by T2. Alright, for this equation we're trying to solve for the second pressure. First, you have to get the temperatures into Kelvin. So you take the temperature 1, add 273, and you get 298 Kelvins. Then you take the second temperature, add 273 as well, and you get 310. Then you input all your values in. Since you have 2 Kelvins, they cancel each other out, and you're left with ATMs, and your answer should be 1.96 ATMs for your second pressure. The last gas law we're going to talk about is the combined gas law, which means you're taking all 3 of the laws and you're combining them together, meaning you have pressure, temperature, volume, all in one. Alright, for our equation we're trying to solve for the second pressure. First, we have to again add 273 to each Celsius and get our degrees in Kelvin. Once you do that, you can input all your values. So you have 2 milliliters, they cancel each other out. 2 Kelvins, they cancel each other out. So your pressure should be in ATMs. After all that, your answer should be 1.66 ATMs. Third law. That went well. Are we going?